Hi, for today's lesson we're going to take a look at some right triangle trigonometry. This is the beginning of a unit where we're going to be using side lengths on right triangles and angles in order to find missing components and also in order to solve some application problems. Alright, so if you take a look at the notes here, you can review a little bit of what we went over in class. We checked out how to label right triangles. The first image here is a little bit of a review. You can see that the side on a right triangle that's across from the right angle is always called the hypotenuse. The two sides that create the 90-degree angle are both labeled legs. Alright, in class we also took a look at how to use the Pythagorean theorem. When you're given two sides of the right triangle, you can use the rule a squared plus b squared equals c squared in order to figure out the missing part. On this example, you can see that the hypotenuse is labeled 27, and there's a C there, circled, kind of showing that that's the side that we know. And we also know that one of the legs measures 12 units, and that leg is measured A. So using 12 for A and 27 for C, we plug those numbers into the Pythagorean theorem so that we have two variables with numbers, and we only have one unknown variable. In this case, it's b. So now our equation reads 12 squared plus b squared equals 27 squared. Once you have it set up like this, then it's just a matter of using algebra to solve for the missing value. Our first step is kind of just following order of operations. And so we have to square 12. That turns out to be 144. And square 27, which equals 729. Our next step is to try to isolate our variable. Isolate means get it all by itself. Right now there's a 144 being added onto the b squared, so we can subtract that away. If we subtract 144 from one side of an equation, we also have to subtract it from the right side. That's an important part of keeping it balanced so that our equation stays equal. Eliminating the 144 leaves us with b squared equaling 585. In order to find our final solution from there, we do the opposite of squaring a number, which is taking the square root. You can leave the answer in exact form, which would just be 585 underneath the radical symbol. You can also say the square root of 585. Or if you want to get an approximate with some decimal values, you can go ahead and put it into the calculator and then round it off to as many place values as you'd like. In this case, I said it's approximately 24.187 and just left it rounded off in the thousandths place. Okay, so that was a little bit review of how to use the Pythagorean theorem, which is something that you guys have had a lot of practice with over the years, and your right triangles. So now we're going to take that previous knowledge and build on it. We can label right triangles a little bit differently for trigonometry purposes. Notice on this diagram that the side length across from the right angle is still labeled hypotenuse. So that's still good. Now our legs have more of a specific name. They're named according to how they line up with a given angle inside of the triangle. If you look inside the triangle, there's a little symbol. It's a Greek symbol. It looks like a 0 with a little line through it, like a little baseball cap. That is pronounced theta. Theta is just a Greek symbol that we use to label an angle that we don't know the measure of it yet. So Sometimes you'll see that. Off in the margin here on the side of the paper, you can see some other names that we use for angles. And you'll see these more as you advance in math. So the first one looks like a little fishy, and it's called alpha. And the next one looks like a capital B with a rounded top, and that Greek letter is called beta. Okay, so back to our triangle. In this diagram, on labeling, the side that is across from angle theta, it's directly across, is called the opposite side. The adjacent side is labeled according to its position, and it's actually touching angle theta. So that's why it's adjacent. Adjacent means next to. So if you're sitting next to someone in class right now, they are adjacent to you. Now if you notice, there's actually two sides that are touching theta, but one of them is the hypotenuse. So that side already has a special side, so we're not going to rename it. We're going to keep it named the hypotenuse, always and forever. Okay, so you can kind of see how we label right triangles. And this will help us with our side length ratios as we work on trigonometry. Okay, and then if we go down in our notes a little bit, we can see some of the uses that this has for us. So, like I mentioned, we can create ratios. Remember what ratios are? That's just making a fraction pretty much. It's a comparison of two things. You can use ratios a lot of different ways. Like if you're driving in a car, you can talk about how many miles per gallon you get. So you're talking about two different things. Miles being one thing, and the number of hours or amount of an hour being the other thing. So it's a comparison of two things. Here with right triangle trigonometry, our ratios are always made up of two different sides of the triangle. Alright, and we can see the three basic trig ratios written at the bottom of our notes. The first one is called sine, the second is cosine, and the third is tangent. So, you guys might have already heard about those before, but here they are again. Sine is abbreviated SIN, cosine is abbreviated COS, and tangent is abbreviated TAN. Okay, so each of these are just special names for the ratios of two sides of a right triangle. So if you look at the sine of theta, the first one here, it is equal to the opposite side divided by the hypotenuse, or opposite over hypotenuse is another way of looking at it. So looking back up at our triangle diagram, the sine of theta equals opposite over hypotenuse. So it's talking about if we knew how long this left side of the triangle is, we would plug that number in for opposite. And if we knew how long the hypotenuse was, along here, it looks like maybe, I don't know, 6 or 7 units. It's just a rough sketch here though. We could take that value for hypotenuse and it would go in the denominator of our ratio. So all of that together will be plugged in with some future problems where we can actually try it out. But that's how you set up the ratio. Cosine is similar, only instead of having opposite over hypotenuse, it's going to be adjacent over hypotenuse. So if the side that you know the name of the side that you know the length of is right next to your angle, you're going to be using the adjacent side. And then if you also know the hypotenuse, you would use cosine, adjacent over hypotenuse. Okay, last ratio is opposite over adjacent. So this is a case where maybe you don't know how long the hypotenuse is, but you can still create a helpful ratio by using opposite over adjacent. And many of you have heard of this little saying that kind of helps us remember which trig ratio goes with which ratio. Yeah, talking in circles. So you can remember it by looking at SOHCAHTOA. SOHCAHTOA. So, if you spell it out, S-O-H is there, Ka, C-A-H, and Toa, T-O-A. And I wrote it with a little slant mark, kind of like a fraction line, in between the O and the H, and in between the A and the H, and the O and the A, to remind you that that's just another way of looking at SOHCAHTOA. It kind of indicates that, hey, we're taking those letters there and remembering that they stand for sides on the right triangle. Okay, we will be practicing some math problems using sine, cosine, and tangent very shortly. But in the meantime, go ahead and make sure that you have good, clear notes that make sense to you, that you've labeled your right triangle parts, and if you have any questions, make sure that you bring those up in class. Thanks.